Good morning, good afternoon, good night, wherever you are. I'm Felipe Hoffa, developer advocate for Snowflake, and I'm today here with the famous Jeff Holland from Snowflake, product manager and excellent live demo presenter. How are you doing, Jeff, today?
I'm doing so good. I wish the viewers could have appreciated us backstage, Felipe. I have not laughed that hard in a very long while. I will take any opportunity I have to hang out with you on a LinkedIn Live.
Oh, I'm so happy to hang out with you and all of our friends that are watching us right now. I see that LinkedIn is live. People are the number is going up. We are live on LinkedIn, on YouTube. We love your messages, your questions. If LinkedIn doesn't send me your message, because sometimes it doesn't, just go to YouTube and send us your questions there. So, Jeff, can you do a little intro to who is Jeff Holland for those that don't know yet?
Yes, great to see you all. Thanks so much for tuning in as we're going to talk about Python data pipelines and Snowflake and a bunch of exciting updates around Python. So I'm a product manager at Snowflake, focusing on a lot of the building blocks for how you can run and write and author your code inside of Snowflake. So Snowpark, Python, a lot of the developer capabilities and developer features is what my team is focused on. Been at Snowflake for a little over 2 years now. So great to have you all and great to chat and answer any questions you might have.
Yes, and this have been amazing 2 years working with you, Jeff. So before we start, I have a couple links open for anyone that wants to go deeper into our topic today. What's new in Python and Snowflake? So we have this webinar, End-to-End Python Data Pipelines with Snowflake. This already happened with Chi, Manuela, and Doris. Any favorite topic from this webinar, Jeff?
The topic is awesome in general, in terms of all of these things. I think for me, the one that I'm the most, I'll pick a favorite. It's the DevOps stuff. I really love the DevOps capabilities that you can do with Python pipelines across the Snowflake CLI. Now we've got pieces in VS Code. So that's my favorite of this webinar recording, if you go check that out.
Oh, yes. By the way, I have to say, it's been 2 years since you joined us, and you have done an amazing job with DevOps for Snowflake.
I love DevOps. I love devs and I love ops.
Exactly. I see you producing content from day one on DevOps. So we have that. We also have working with data frames in Snowpark Python. What's new with data frames in Snowpark Python?
Oh, a lot of exciting things. I think the biggest one, which we'll talk a little bit about today, is the ability to use Pandas data frames within Snowpark Python. And so, the traditional Snowpark data frame, very Spark, PySpark-like, now expanding that to Pandas, I think is the biggest what's new here. We'll even probably show that here in a few minutes.
Pandas is really cool. By the way, we already have people asking questions online.
Yes.
How is the performance of running Python build pipelines versus native SQL code? We are going to go into that in a second. But I also want to show this to people, this report, Snowpark price performance, customer results. It's not only us, Snowflake, saying this, it's also people migrating from Spark to Snowflake and giving us their numbers. Any thoughts?
Yeah, this is a super important part of my job and my team's job, which is hey, for what we're building, for what we have here in Snowflake, like how is this helping your teams? So I'm getting on phone calls multiple times a week with users to understand all of the aspects of how the product is working. But one of the most important ones is the before and after, like before Snowpark and after Snowpark. So we took a bunch of these learnings. We did some official research here. We got dozens of customers. We threw them together. We said, let's share that out with the community. And the results here are super, super exciting. So significant. I don't know if you can even see the numbers here in terms of the percent increase. I think it's at the very top headline of these results that it shows here. Oh, there we go. See, like 4.6 times faster and 35% cost savings for folks who were running workloads with Spark before, taking their data, often stored in Snowflake, pulling it out, processing it with Spark. Spark's great technology, to be clear. Like there's a lot of folks who use it, a lot of folks who love it. But so we've tried to take the best parts of Spark, add on some Snowflake superpowers here. And these results are, I guess they speak for themselves in terms of like when you're able to push down that processing directly to the data. The whole report has more details, but this is time and time again the news that we're hearing from those users as we're talking to them. And that gets me really excited because that price and performance savings translate directly to business impact for our users themselves. So definitely we're checking out and seeing what other folks' experiences have been for people who are doing data pipelines or processing, especially with frameworks like Spark.
Yeah, it's beautiful to have seen Snowpark from its beginning, how at first we could only move certain use cases and the team has kept improving performance to this point. Like it really makes sense to migrate from Spark to Snowpark in many cases. Uh, no, that's the performance question from Aravind is more about Python build pipelines versus native SQL code. Any thoughts on that?
This is one of my favorite parts about the inception and even how we created Snowpark. So if you think back, we're like, hey, we know Python is a super powerful language, very flexible, has all these libraries, capabilities. How do we make sure that folks can bring their Python code and run it efficiently, securely, and at scale with their data? And there's a number of ways we could do that. You could have adopted a different set of technology. But for us, we were like, look, we want to make sure that the same speed, performance, governance, efficiency that Snowflake has, Python gets it in the same way. So the answer to this question is the performance is it's negligible, the change between the two, because what we're doing between the two worlds, whether it's Python or SQL, is both of them that gets pushed down to the same data processing engine. So if you like SQL, if you're very comfortable with SQL, you want to write your dynamic tables in SQLs or your pipelines in SQLs, great. We love you. You're awesome. If you want to do the same in Python, great. We love you. I love you maybe a little bit more. And you're awesome as well. But your performance between the two won't be impacted. So it's not like, oh, your Python pipeline is running a little bit slower. It takes longer for it to crunch all that data. You should move it to SQL for performance. Not an issue at all. It's one engine behind the scenes. So you can really just choose the language, the capabilities that you're most comfortable with.
Yes, and I have to say, when we're doing this performance review, it's especially when we are using the data frames, either Snowpark data frames or Pandas data frames. So those, if you're using Python for that, it gets translated into SQL code that basically has the same performance. But you can also write Python UDFs that sometimes the UDF can be slower than doing the equivalent with SQL.
Yes, or like there's a step. So if you think of like let's say there's a step in your pipeline where you're, I don't know, encoding a value with something, there is a step in the process where we have to like spin up the Python environment and make sure all the packages are set up. So it's fairly low, it's fairly minimal. Like we've done a lot to optimize it, but there will, like when you just run SQL code, we just push the SQL straight down. So if you write like a SQL UDF or a Python UDF, you'll notice that there's like that extra compilation time on the Python side, but it's a one-time hit when we're spinning up that environment. It's fairly negligible, but you are correct, Felipe. There are some components where, and even then, like the spin up time for Java is slightly different than the spin up time of Python. That's more to do with the differences between Python and Java and spinning up those processes than it is necessarily, something that we're doing special or different on our side.
Yeah. Now, and then I love the flexibility that it gives you, because there are things that SQL just cannot do. One library import from Python, start, you have the whole power. Another question, typical question from Juan Manuel Romero. Welcome to the show. Is this being recorded? Yes. The same link where you're watching this now, it will be immediately available when we finish for you to watch and share with everyone, because we love doing this live and it's immediately available for everyone. And the last link that I have for people before we go deep is getting started with data engineering. I cannot see the full title, but what's the name? Getting started with data engineering using Snowflake notebooks. We're going to talk about notebooks today. People can do the whole week start. So that's a huge overview, but let's put some context here. Thank you, Jenna, for sharing the link. What's new in Python and data pipelines, Jeff?
So a few things I'll highlight, and then Felipe, I'll let you kind of take where we go. I mentioned a few of these from the get-go and even here. So if you're just watching now, if there's a few things that if you don't know about, I would strongly recommend you check out if you're interested in data pipelines. First one is notebooks themselves. Notebooks is a huge benefit to like just getting up and running and starting to write your Python code very easily within Snowflake. So notebooks is currently in public preview. It'll be generally available here soon. So keep an eye out for that announcement. But like you just get going. I have, I don't know, 30 notebooks in my Snowflake account that I'm just like, oh, I want to go answer this question about telemetry or usage of our products. Super easy to use. So that's the first one. Second one I talked about before, which is Pandas, that we'll talk about here in a second, or whenever, Felipe, you tell me to. And then the third one I want to highlight quickly is around, especially when we talk about data pipelines. Oh man, there's so many new things. I might sneak in a fourth. There's some Python APIs that are very helpful for building Python data pipelines. In fact, if you go look, there's this task set of APIs where you can create what are called DAGs. Oh man, directed acyclic graphs. Is that what the DAG, the DA, and the GA stand for? Don't quiz me on that. But DAGs, like this notion of saying like, here's task 1, here's task 2, here's task 3. I want task 2 to depend on task 1. You can define all of that in Python code and run it. Oh, look at this, Felipe, you're ready to go. Like if you scroll down, there's a few code samples here of just what I'm talking about. But like here, yeah, you can create tasks in Python. You can create pipelines in Python. And these will all translate into managed and scheduled tasks within your Snowflake account. So this is another one that is definitely worth noting as you want to build data pipelines in Python, because it lets you stay entirely within the context of, oh yeah, this one I love. Like this lets you stay entirely within the context of Python and create that DAG that I mentioned before, which now I'm terrified that I defined it wrong. Directed... Yeah, acyclic graph. Hey, I did pretty good.
You got it.
So those are 3 big new ones on the data pipeline front. And like I mentioned before, a lot of folks that we see building these pipelines, often they're using technologies like Spark. Previously, they're doing data pipelines in Python on external processing engines, wherever that might be, and being able to push more of that processing either through Snowflake libraries like this task one we're showing now, or even just pushing that data pipeline processing down to the Snowflake engine does a lot. And I'll actually grab a quick question that Jalindar just asked. I don't know if you can highlight it here, which is, how is this different from Airflow? Airflow is super popular, super commonly used, but like this one I'm showing, Airflow also has DAGs. The big difference here is, rather than relying on, some orchestration engine that is managed somewhere else that your team is managing like Airflow, this translates into, in Snowflake, what are called like Snowflake tasks and Snowflake trigger tasks. And so it's all built and runs all on your Snowflake account and on your Snowflake compute. Doesn't mean you can't use Airflow. We have a lot of very happy Airflow customers. I think it's great tech. But if you want something that's just kind of like out of the box, you don't have Airflow maybe up and running now, or you don't want to manage it, this is a great option here. So great question.
Yes, I have to say, we love partners. Like Snowflake integrates with the larger ecosystem. We have Snowflake notebooks now, but we also love Hex. In fact, Snowflake is an investor in Hex, and they write great notebooks. But having a native option that takes 0 effort to integrate, and it's just available there, it's also a really cool option. So we give people options. I'm glad that you can also talk about the differences between what they have and what we can see.
Yep. So those are a few of the new things. And happy, Felipe, whatever one you want to jump into, happy to dive into a bit more.
Perfect. Oh, I'm sorry, I got some noise in my headphones.
The producers are on the wall. They're like, change topic, Felipe.
Yes, no, sometimes I click here and starts playing a video from some Chrome tab, and it's very weird. Anyways.
Multitasking.
But yes, Yolander says, thanks, it makes sense. It's great to have tasks that depend on nothing else. You can just ask Snowflake to run it in a cron and everything else. But if you have a bigger tag, something that you're running within the company, Airflow is perfect. Good. What else is new, Jeff?
Okay, so let's spend a beat here as we double click into some. Oh, double click. There was some Wall Street Journal article this last week around double clicking, and I'm super self conscious now every time I say it. Let's dive deeper into a few of these things. I'll start, Felipe, by talking a little bit about Spark. We talked about the sum on the performance things. I think the few things I'll highlight here, really the kind of crux of this is Python, specifically, a ton of huge growth in the community all up. And very often, very common, especially before Snowpark was an option, folks would be like, okay, well, how do I run Python code efficiently and at scale with my data? And Spark was often the choice that many teams did, because what Spark does really, really well is it takes, your PySpark code, it translates it behind the scenes and helps you distribute it. Because when you're working with large volumes of data, volume of any kind of like medium to large to extra large size, it's very hard to run that on a single machine, a single box like your laptop. You need to go and scale this out across a bunch of managed infra. So Spark does that very well. I mentioned kind of at the beginning for those who are watching that we wanted to make sure that folks with Snowflake had a really performant, easy to use way to run Python code in Snowflake. And while Spark has this huge community, there's a lot of amazing things about it. There were some things that we looked at and were like, okay, is there something we can do to improve on this? Can we make this super easy to use? Can we make it so you don't have to worry about Z ordering or partitioning? And more importantly, can we make sure you don't have to worry about managing a separate compute environment and a separate compute engine to do your processing for your data that's already sitting here in Snowflake or managed and governed by Snowflake? So Snowpark is the new engine built natively on top of Snowflake that does the same capabilities of Spark. In fact, we purposely built the Snowpark API so folks coming from a Spark world would have a familiar interface. You'd be hard pressed to be able to say like, oh yeah, this is the difference here. You take a sample of Spark code, you paste it into a Snowflake notebook running Snowpark. 9 times out of 10, it's going to work just fine. But the big differences are it pushes all of the processing down. It still does the distributed thing. It still spins out across multiple instances, but it pushes all of that processing down to Snowflake. And the result is you get these massive price performance benefits. So it's not that, there's some incredible breakthrough that we've had at Snowflake that makes it so that this is so far superior than any distributed engine. This is really just around pushing the processing down, removing the need to move data outside of where it's stored or managed and push it to a different platform, managing 2 platforms at the same time, modulating and configuring those pieces. No, it's one piece. You write your distribution code, you write your Python code. We'll take care of the heavy lifting. It's fully secured, it's fully managed. So that would be one big piece of like, if you have not used Snowpark today, if you even haven't tried it in the last year or so, maybe you tried it when it was earlier in preview or you name it, definitely recommend checking it out. We've really been working hard to flesh out those capabilities. And yeah, these results, as I mentioned before, speak to themselves. So that's the first big data point for anyone doing Python data pipeline. Definitely worth looking. And we even have some tools, Felipe, I guess, as I jump a little bit ahead, to help you in that migration. So we have like a Spark migration or Snowpark migration accelerator that will you can point it at where you might be running PySpark today, and it will actually help you auto convert for those, 1 time out of 10 chances where there is a slight change because we are doing something a little bit differently. It will help you migrate it automatically for you. So great tools to know. And Jalandhar, to your question, I think the big architecture difference here is that rather than pulling all of the data out somehow into memory and processing it in memory, doing all the results here, and then writing back the results or pushing them back down once you've done all the processing, we take it one step further. And you still write everything in Python. I'll show a notebook here in a second. But we take all of that processing and we push it down from the get-go. So your data never has to leave. We never have to pull data into memory for these large-scale ones. You only pull in processing where you need, but we push all of the data down. So it just reduces the need for any data movement. It enables us to tap into Snowflake's Elastic Engine, which is just like industry-leading, incredibly powerful. I don't understand all the amazing stuff that makes it work as somebody who comes from like a Python app background and not a data background, but it taps into that power. And so those are the big differences, removing all those steps that result in the price performance pieces. So that would be the first one I would want to give people a heads up for is if you're building data pipelines, you're building them in Python, Snowpark, especially if your data is being stored and managed through Snowflake, is going to be the absolute best place to run that code.
Yes, I like the simplicity of the setup. It's Snowflake is the place where I was writing all my SQL, and suddenly I can, if I have code that's Spark that's using data frames, I can move it into Snowflake and remove elements from the architecture because everything gets simplified into one single platform, one set of rules, one set of policies, and
That's
it's
it.
pretty easy to run and fast, as we see from the results.
And if you're really, really interested, like you can go to
Mhm.
GitHub and type in Snowflake Snowpark, and you can find the GitHub repo where we're contributing and adding and coding, and developers right out there are working every single day. You can go poke around it for yourself too. It's all there inside of GitHub, all the work that the Snowpark code is doing.
Yes, I have a question from Stuart about
Yes.
dynamic tables, but
Stuart, data superhero Stuart. I'm a big fan, Stuart. I hope he's wearing his
yes,
cape.
yes. Let's answer first this question from Aravind, just to stay on the Python world,
Sure.
but we are paying attention to dynamic tables. So, Python, how are the Python packages managed by Snowflake? How is the customer expected to manage pipelines with incompatible Python packages?
Yes. So the general answer here of how Snowflake packages are managed, or Python packages in general, is that we embed a bunch of packages directly into Snowflake. We do that through a partnership we have with Anaconda. So Anaconda is securely building and curating the set of like the top requested packages. We add, I don't know, 5 or 10 of those every single month onto the list of packages per people's requests. So that's just right out of the box. You just say, I want these packages. They're already in the Snowflake environment, they're already secured. You can start using those. Now, there are instances where you want to use a package that is not inside of the Anaconda package provider. I think, Felipe, you wrote a blog post, I don't know, probably a year and a half now about, I want to say some date library that did something around holidays, right? That wasn't yet in
Yes.
Anaconda. Yes. So in that case, we do have some tools both through the Snowpark library, but also through the Snowflake CLI, where you can manually take a package and you could upload it into Snowflake to access. So if you want to manage something there. Now, there are some gotchas there. If that Python package behind the scenes or under the covers has some what we call native code, which is like C++ code that gets compiled down to binaries that gets packaged in the Python library, that we don't let you bring your own right now directly into Snowpark unless you go into container land, which you can do. So those ones is where you might hit some gotchas. In that case, we've got some guidance in terms of like, first, let us know the package you want to do so we can add it. But yeah, here's the channel of, I was even going to look at like whatever the list is today, however many are on this list. It's quite extensive of the packages provided. But if you bump into one, like I said, you can upload your own unless it has native code. If it has native code, your options are you have to kind of manage that through a container environment right now, or let us know. And we are actively working as a team. I will let you know to make it so that more and more packages and even more packages that you want to customly upload can be supported. So it is something, Arvin, that you can bump into, but there are options across the board and
Mhm.
more to come, I guess, is how I will leave that teaser out there.
Yeah, I have to say, for me, one of the hardest things a couple of years ago was when I tried to install Prophet in my VM.
Mm-hmm.
Managing those dependencies was crazy. Python dependencies are crazy. But now with Anaconda in Snowflake, I can say, hey, bring me Prophet. And everything has been taken care of. So uh, those packages are pretty cool. Now, Anand wants to know how can we add a specific version of package into Snowpark?
So same
And
one
let
through those
me,
tools that I mentioned. Yeah, you can if the version is not already here, which we do let you like select the versions, but if we have the oh yeah, like this tool. Oh look, you even have, yeah, so you can specify. So here you can like pin to say I want NumPy 1. If you want to add a specific version, like something that's not an Anaconda, we also let you provide some version annotations there, and you can upload the version that you want and then reference your own specific version.
yeah, and this is a very important example because NumPy now it's
Version 2,
jumped from
right?
version 1 to 2, and
Yeah.
that's breaking so many data pipelines around the world. This is not a Snowflake problem, it's just there's a new version. So this is, for example, if I write a UDF, how I can ask for, this is a SQL UDF with Python code, but here I can just ask, hey, Snowflake, Anaconda, make sure to bring me something on NumPy version 1 and the future, and nothing from two. So yes, you can do some specific pinning for that kind of example.
Yep.
Cool. And of course, Snowpark APIs available in other languages like Scala and Java.
Yes, and yes, I'm glad you asked those two languages. So we have Snowpark data frame support, which is kind of like lets you do the data transformation, the UDF store procedure in Python, Java, Scala, or containers, like I mentioned. You can also write code in JavaScript if you have JavaScript functions or procedures you want to write. We don't have a JavaScript data frame API, though, so you can't do some of the data frame things. So generally, when we talk about Snowpark, we talk about Python, Java, Scala, and then kind of the plus containers.
Yes. Speaking of data frames, before we go to see the Pandas data frames, before we run out of time, I mean, I really want to see Pandas data frames. Do we quickly want to answer Stuart's question on pipelines?
Yes, we do. Yeah. So this is a great one, which is like I talked about this task and DAG Python processing. And right now, this Python API more or less translates one-to-one with tasks behind the scenes. And Stuart's calling out like we have this amazing, very, very cool feature, which is dynamic tables, which in some cases can simplify the need of like, oh, maybe I don't actually need a bunch of task pipeline. Maybe I just want to create a dynamic table, like create table as select with a lag, which is a super cool feature. Can we combine those? I will say right now, it's still, you have to be a little bit more explicit. You can define dynamic tables through Python, specifically through like the Snowpark data frame libraries. You can say like, write this as a dynamic table. Here's the lag, here's the warehouse, and we'll keep that automatically refreshed. But combining the task and DAG API with dynamic tables isn't as kind of like combined as you're mentioning. But Stuart, I don't know if you've talked to folks on the product side. Again, since you get a product person on the LinkedIn start, I'll tell you this is absolutely something that we've been doing some active discussions on internally as a team. So our data engineering experiences team has been doing some really, really interesting prototyping and previews on a better combination of the two worlds, I think is what I would leave it as. So if that's something that you're interested at, feel free, anyone watching, to send me a note, and I'm more than happy to connect you with the team there who's poking into it. Jeff.Hollan@snowflake.com. Shameless plug. So great question. Possible today. We're exploring how we can make it even more combined. To your point, it would be interesting.
We love feedback, and that's why we're live. Should we jump to your notebook?
Let's do it. Yeah, we only have a minute or so left. So the other thing I wanted to highlight is this Pandas capability that we have, and also showing notebooks at the same time. So two birds, one stone. So here, I mean, first things first, I mentioned Snowflake notebooks currently in public preview. Is super easy to just get up and running and starting to explore and manipulate and manage your tables or even build pipelines. One thing I wanted to show here was this new Pandas integration. And there's one specific cell, or two cells, I guess, that I think really do a good job of showcasing why using Snowpark Pandas might be more beneficial than just using generic Pandas. Now, Pandas super popular. Over 50% of all Python users are actively using Pandas. So it's like bread and butter, one of the core tools. So I have a quick scenario here. I'm not going to walk through the whole scenario, but there's a data set actually in the Snowflake marketplace, which has a bunch of economic data. It's like stock ticker data, stock price time series data that Cybersyn, one of our partners, has helped curate and provide. So I want to do some data engineering pipelining on this stock price data. Now I have two cells here. One of them uses Snowpark Pandas data frame. And so I can say, hi, I want to load all of the stock price data. I think this goes back to like 2009 or something, or 2010, something far back. I want to load in all of the data into a Pandas data frame for me to start manipulating and manage. And you can see here, I won't run it right now. I ran it, I don't know, 30 minutes ago. It took 8 seconds to load, what is this again? 68 million rows into a Pandas data frame. 8 seconds. And this is using the new Pandas data frame capability. So you'll see up here, it looks like Pandas, it feels like Pandas, but I'm actually telling it to use the Snowpark Pandas plugin. Now, why this only took 8 seconds is because we don't actually have to download all 68 million rows into Pandas on my notebook or in my laptop or wherever I'm doing my development. In fact, it's pushing and keeping all of the data inside of Snowflake, inside of this table, and it's just creating a Pandas wrapper on top of it. Now, to make that more clear, I'm doing the same thing, but I'm doing it a different approach in the second cell, which is rather than using Snowpark pandas, I'm just going to use regular pandas. So I'm going to, like, if you've used pandas with Snowflake before, you've probably done something like this, which is you create a Snowflake connection and you say, hey, I want to fetch all the data and create a pandas data frame. Now, this is a vanilla pandas data frame, a non-Snowpark pandas data frame. But here I'm taking those 68 million rows and I'm loading it into pandas so I can do the manipulation. Now, remember before this took 8 seconds? If I do it this way, it takes 153 seconds to read the data. Now, why that is because it's truthfully taking 68 million rows and it's loading them all into pandas, in this case on my notebook. So it takes 2.5 minutes. And then every time I do an operation, like if I was to continue to do this with the regular pandas thing where I'm doing, filtering and joining and whatever else, that's also going to take a bunch of time because my laptop, my notebook, the CPU starts to smoke and bubble and pop because it's having to push all this data into my current processor. Whereas in Snowpark and Snowpark pandas, I can do the same things. Like you'll see later on here, I'm still saying like pandas head and pandas, here I have a where clause where I'm filtering to only the New York Stock Exchange. I'm doing this just like pandas, but when I actually run it, everything's running super, super fast because it doesn't actually have to pull all that data out. I'm still using pandas, but Snowpark pushes the data down. My warehouse is being scaled out. It's doing all the processing there. So this is a super, super powerful tool for those who might be more familiar with pandas than Spark to start manipulating, building pipelines on top of your data. Even though this is huge data sets, you see all these operations are super, super fast. Now, once I do all the things that I want to do, which I won't walk through for the sake of time, I can even do things like schedule this. So I could say, hey, run this every single day and write my output to a table, or use that task API that we were showing earlier and put some tasks around here. So that was just a little bit that I wanted to kind of showcase to help make real, which is, it's not just that we have some better library wrapping for pandas, it's that we're actually doing some pretty powerful capabilities of letting you use all of the familiarity, the power, the flexibility, the openness of pandas, but we're doing all of it without moving your data. You don't have to push and pull all that data in, worry about memory errors, you name it. You just use the Pandas API. You literally just change your import statements and you're off to the races. And it will now connect to Snowflake and do all the other for you. So that's what I wanted to show, Felipe, to kind of make this a bit real for folks.
That's beautiful, because a couple months ago, I was telling people, yes, this will not be fast with Pandas. Move to a Snowpark data frame that looks like Spark. It's also a data frame. But now I can tell people, keep using your Pandas as you know how to use it, but switch to the Snowpark Pandas data frames.
Exactly right. That's it.
Yes, from 150 seconds to 8, that's pretty sweet.
I'll take it. Now what do? Instead of getting my cup of coffee, I actually have to keep working, which is, I've got to figure out something else to take a long time.
So, yes, we can take a minute to answer questions, but I think people are more like anything celebrating. Like, thank you, Henry. Thank you, Arundev. Thank you, Anand. And as Jalandar says, thanks, Jeff. Any thoughts as we close, Jeff?
Let me see if there's any last little nuggets to pop in here. No, I think this is great. Honestly, you brought the first ones, and I think earlier on Jenny even posted the link. I think the biggest thing I would say is give Snowpark a spin, especially with notebooks. I got to tell you, I use VS Code and the Snowflake CLI quite a bit. But when I just have to do some really quick processing, open up that notebook, having the connection right there managed using my warehouses. So try out notebooks. Check out that quick start of data engineering with notebooks as well, if you want an idea of what to go build. And I guess the last thing I would say is let us know. I gave my email earlier, jeff.hollan@snowflake.com. If you have any other questions, if you built something really, really cool, if you have ideas of what we could be doing to make you and your team's lives easier, let us know. Thank you so much for joining, for participating, for asking great questions. And hopefully this was helpful for all of you.
Thank you, Jeff. And let me call out that we have available this quick start for anyone to play with. The quick start is super updated. They know about notebooks, and in this quick start, you will learn how to load data from S3. You can even read Excel files with Snowpark. How cool is that?
Everyone loves Excel. Yes. Talking about the most popular data tools.
Excel is never going away. So yes. access data from the Snowflake marketplace. Oh, you can also get data from Google Sheets using the Python code with Snowpark
Yes.
and using external
External
access.
access and all that stuff. Yep.
Yeah, Snowflake notebooks and the Snowpark Data Frames API to build data engineering pipelines, do things with Snowside, execute SQL scripts from your Git repository. Jeff loves this one.
I do love Git. Anything around DevOps and Git. I mentioned that at the beginning. Soft spot on my heart.
Exactly. So open source, how to use open source Python libraries from the Anaconda channel, the Snowflake Python Management API to work with Snowflake objects, Python Task, the AG API, as Jeff mentioned earlier, build CI/CD pipelines using the Snowflake Git integration to Snowflake CLI and GitHub Actions, also something that Jeff loves and has been a big part of, and deploy Snowflake notebooks from dev to prod. Especially,
I don't know if there's a more exciting list anywhere that you could have read through in terms of like who doesn't want to learn all those things. Go try that quick start out.
Yes, and it will
only takes 90 minutes.
90 minutes. And
all that stuff.
gather your questions. We will love to answer them on the Snowflake forums. I'm always on Reddit, and we will be back with a live show, hopefully with Jeff very, very soon. DevOps FTW for
the win. Thank you, Stuart. Yeah, Stuart's a DevOps true and true as well. He's been super helpful in giving this feedback as well. So thank you to our data superheroes. Another thing you should all keep an eye on. And yeah, there's one last question that snuck in before we go offline, which is how to handle backwards compatibility with older versions. So it is like we try to make this as easy as possible, I guess I would say, in terms of letting you switch. But for instance, like Python 3.8 is going to hit end of life up here in the winter of November, like November this year. So you do need to make sure that you're staying on top of your latest versions. We do our part in terms of making sure we have the right packages for each of the different language runtimes. But this is something that you do need to be aware of as a team, of making sure that you are using the right versions. If you want to use a really old version like Python 3.5, we just can't help you much there. Like it's not being patched, it's not being maintained. We got to make sure that we have, serviced, secured, all those things runtime. So there's other tools out there. Like it's not too terrible in the Python world, as long as you're not coming from Python 2. As long as you're in the Python 3 world, usually things are fairly smooth moving up the stack.
Yes. And with that, it's time to close. Any last word, Jeff, before the bear dances?
Just thanks, everyone. Reach out if you have any questions and let us know what we can do to help.
Yep, subscribe, like, connect with us. We love you all. Time for the bear to dance us off. Thanks, everyone.